audience. Today's topic is regenerative medicine and the benefits it can provide to an ailing body. When people first hear the term regenerative medicine, the first thought is stem cells. And once that thought comes to mind, the next thought is either anger about the fact that stem cells often come from fetuses, or you're really happy about the fact that it could cure your family member with Parkinson's disease. Regenerative medicine is actually about fixing parts of the human body that have degenerated because of age, illnesses, genetics, and other diseases. While there are many variations of regenerative medicine, it is, quote, intended to functionally repair tissues and organs using cell-based techniques, thereby avoiding the need for replacement therapies, as stated by Dr. Mehta of Orthopedics Plus. A stem cell does not actually have to come from a fetus. According to the Mayo Research Clinic, a stem cell has, quote, the capacity to differentiate into multiple types of cells, and the cell must be able to self-renew. The ability of a cell to simultaneously maintain the stem cell pool and generate daughter stem cells that can terminally differentiate into numerous tissues. And as you can see on this little diagram here, those are different options that stem cells can be used for, and describes the unique capability of stem cells to undergo asymmetric cell division. There are different kinds of stem cells. The most commonly known type are called totipotent stem cells, and they're extremely dynamic and can produce any type of stem cells you could ever want and in very large quantities. They are controversial because these are the ones that are found around the placenta or in an embryo that is no more than 32 cells large. They are highly debated because on one side they come from a fetus, but on the other side they can create muscles and tissues and organs on a whim. The less commonly known stem cells are adult stem cells, and they're found in all of us. They're found in your hair follicles, your intestines, and bone marrow. These stem cells are restricted and can only, I just got a weird face, can only generate cells of the same type. So your hair stem cells can only generate hair. They're very limited, and as opposed to embryo stem cells, they can only do certain things. But this is only a small part of regenerative medicine. There are 4 major types of regenerative medicine, and they are stated by the University of Pittsburgh. The first type is creating artificial devices and organs. In this area, the focus is on improving the quality of life for patients in the hospital, so maybe they don't have to wait as long for a heart transplant or liver transplant or things along those lines, and it uses biometrics and things like that using your own cells. The second part includes fully artificial organs and biohybrid organs. This has the potential impact to sustain patients during their wait for a new organ, and it helps reduce the number of rejections per organ transplant because it's using your own cells instead of somebody else's cells. Another part is tissue engineering and biometrics. There's a very long waiting list for people in need of heart transplants, and everybody knows somebody who has needed a new heart valve. Current procedures include a very high risk of infection and blood clots, strokes, and many other complications. Once this area has been mastered, a person with heart disease can have new valves made from their very own tissues, grown in a lab, just like this little ear. They can have your heart valve made, or an ear if you need one. Previously, it was thought that highly specialized cells found in your lungs, your hearts, and your nerves could not be regenerated, but recently the Mayo Clinic's research has found that they can. And this means the rejection goes down again for something else, and the body can repair itself, whereas right now it cannot repair the pig's valve that you get for your heart transplant. The third concentration includes stem cells found in placentas, but not in the way you might imagine. Everybody is born with a placenta, and in this case, doctors and hospitals keep it and save it for when you might need it down the road somewhere. Sounds gross, but it's not really that gross. This hasn't reached the clinical trials yet, but it's really impressive with things you could do with something that's given to you at birth. And it could really improve, it gets rid of the whole controversial thing behind fetuses. The next part is called cellular therapy, and it's a way to replace cells lost in trauma, wear and tear, or disease. This would be something that's used for a child who has leukemia. they've gone through chemotherapy, they've lost all their cancer cells, but they've also lost a lot of healthy cells. And so you could regrow their own healthy cells in a lab somewhere, and then instead of having to get your brother to donate bone marrow or whatever else to you, it's all done in a lab. Cheaper, safer, painless. The last piece about regenerative medicine is less about the medicine itself and more about getting the medicine to the public. It's called clinical translation, and it's the process of advancing the medicine and getting it into your clinical practices on a daily basis. Every year, billions of dollars are spent in treatment costs for conditions that regenerative medicine can fix. According to the University of Pittsburgh Medical Center, heart valves cost $27 billion annually, with 250 recipients in the United States alone. Heart disease and stroke claim 950,000 lives, costing over $350 billion in the United States. And diabetes affects over 17 million patients, with $132 billion in costs annually. Regenerative medicine has the potential to cut all these costs dramatically by decreasing hospital stays, the number of treatments, medications, and complications related to each disease related to the original disease. The idea behind regenerative medicine isn't to just eliminate things. It's to get rid of the problem that's already there permanently. And it's aimed at reducing medications, extending your life, and providing a long-term solution without any long-term consequences like dialysis for the rest of your life. While there's a lot of controversy surrounding regenerative medicine, that's my last card. There remains a great potential for the things it could